Okay, so we're going to apply the area of a triangle to kind of figure out the law of sines. Okay, so it says use angle A, find the area of the triangle. So if we're looking from angle A here on the left side, okay, the area of that triangle, it's going to be 1/2. The two adjacent sides are B times C times sine of A, the angle, right? If we're looking from angle B, it'll be 1/2 A times C times sine of B. All right. So it says, since these two areas are equal, set the two area expressions equal to each other, right? It's the area of the same triangle. So we'll set this number 1 equal to number 2. So we'll have 1/2 BC times sine of A so it's equal to 1/2 AC times sine of B. Rewrite this equation so that I have A over sine of A on one side of the equal sign. So we can see right here that the 1/2 is going to cancel out and the C's are going to cancel out on each side of the equation. Okay, so what we would do from here, we would have B sine A equals A sine B. So to get A over sine A, we would just divide this by sine of A here. And then that would cancel out, and then we just have to get rid of sine of B here. So you would have from here B over sine B, sine of angle B, is equal to A over sine of angle A. All right. And this is a version of the law of sines. Okay, you can have where like the lowercase letters are the sides and then the uppercase letters are your angle measures. Okay, you can have it written like this, or it could also look something like this. So basically, you just want any two of these ratios. So like here they had A over sine A equals B over sine B. Any two of 3. Same thing for this here. Any two of 3. Okay. I usually write the angle up top, but it really doesn't matter. Like I usually do sine of A over little a, sine of B over little b, so on and so forth. Okay. So this is our law of sines here. And I'm going to write one additional note. You can use the law of sines when you're given two angles and a non-included side, AAS, or two angles and an included side, ASA. We will see that it is possible with SSA, two sides and a non-included angle, but there will be some restrictions. Okay, so this is a preview actually for the next section as well. All right, so let's go to the next slide here to go over a couple of examples. So here we're given the triangle here. It says solve triangle ABC. So when you're asked to solve the triangle, that means that we have to find all the remaining parts. It says C is 103 degrees, B is 28, B is 28 degrees, and then little b is 26. So now we have to figure out how are we going to set up our law of sines ratios, right? So we have one filled in ratio comparing side B to angle B. And if we take a look at kind of what's given to us, we have two angles that are given and then a non-included side. So that's why it's, I said before that it's like angle, side is one of the possible ways that we could use it. So we'll have, we're using sine B over little b equals, and then I'm going to do sine c first over little c. Okay, so we'll have this in the ratio. This is just filling in the appropriate angle measures and side lengths. And then from here, this is just a proportion, so we could cross multiply and solve. So we'll have 26 times sine 103 equals c times sine of 28. And then to solve for c, you would just divide by sine 28. So you type all this now into your calculator. C is going to be about, I'm going to round this to, I'm just going to round this to the nearest tenth. So this is going to be about 54.0 feet. And to solve the triangle here, we're going to have to set up another law of sines, but we can also fill in this other angle. So we can figure out this other angle by adding these two together. So this is going to be 131 and subtracting it from 180. So this is going to be 49 degrees. So we know angle A is 49, and we're going to use that to solve for side A. So we'll have sine of 49 over little a, and then I'll use B again because this was an exact value. We didn't have to estimate anything. You could technically use C, side C and angle C, but it probably wouldn't be as accurate because we had to round that. So I'm going to skip a step here. You guys should be able to see I'm cross multiplying this here, and then you'll eventually get, when you isolate A, it's going to be 26 times sine of 49 divided by sine of 28, and then rounding to the nearest tenth, that's going to be 41.8 feet. All right, so that's example 5 there. And then now let's take a look at this here, number 6. The accompanying diagram shows the approximate linear distances traveled by a sailboat during a race. Sailboat started at point S, traveled to points E and A respectively, and ended at point S. Solve for X. So we're just essentially setting up another law of sines problem. So we'll have sine of 75 over 32 equals sine of 65 over X. Cross multiply and solve. We have X equals 32 times sine of 65 all over sine of 75. Okay. And what I would suggest, guys, is to don't round all these values in between. Don't round. Just do it all in one shot. That'll give you the most accurate answer. And this is going to be about 30 point. For this one, I don't know why I did it, but I did it at 2 decimal places, 30.02 miles in my answer key. All right. So those are 2 problems applying the law of sines.